Welcome to our channel. Today, we are diving into the fascinating world of passive design strategies for hot and humid climates. Passive design is all about using the natural environment to enhance a building's energy efficiency without relying on external tools or devices. Let's explore some key strategies that can transform your building into a high-performance, comfortable space. 1. Building orientation. First up, building orientation. It's crucial to orient your building correctly to optimize climate response. Here are some key design strategies. 1. Place the longest facade in the north-south direction to reduce east-west exposure. 2. Orient the building based on the sun path and prevailing wind direction. 2. Building form. When the shape of the building is more compact, the loss and gain of heat by the building will be less wasteful. The building's form also determines the flow of air inside the building. Key design strategies. 1. Reduce the depth of the building to reduce the need for artificial lighting in the buildings. 2. Keep the building form narrow to help in proper cross-ventilation. 3. Add openings at the right spaces to reduce direct heat gain. 4. Protect openings and walls with design methods like overhanging roofs. It reduces internal surface temperature and increases shading. 5. Consider high-mass construction for better insulation. 3. Zoning. Proper zoning of the spaces at all levels helps set the foundation for the implementation of any passive design strategy. Key design strategies. 1. Cluster the buildings to promote self-shading inside the site. To make sure all facades with openings are open to natural sunlight and ventilation. 3. Create open plans to let in natural light and ventilation. 4. Create enclosed courtyards between buildings to reduce the need for artificial cooling. 5. Zone each space according to its ventilation and lighting requirements. 4. Ventilation. Playing with the existing natural ventilation can eliminate the need for external ventilators. Afternoon heat buildup can be avoided by providing openings that encourage air circulation. Key design strategies. 1. Ensure cross-ventilation in which cool air enters through one opening and warm air exits through another. For cool air entrance, windows, louvers, open facades. For warm air exit, roof vent, higher window openings, facade offset from the ceiling. 2. Create inlet and outlet openings at different heights in stack ventilation shafts to remove warm air from inside and draw cool air inside. Example, atriums, ventilation shafts, ventilation towers, solar chimney, air vents, attic extractor fans, whole house fan, solar-powered stack ventilators. 5. Daylighting. In spaces where daylighting is of abundance, it's important to consider heat gains and glare while designing the spaces. Key design strategies. 1. Place the window opening as close to the ceiling as possible to let in the maximum amount of daylight. 2. Allow filtered excess natural light based on needs and comfort levels. Example, jelly walls, perforated roofs, semi-open pergolas, partly shaded courtyards. 6. Shading. Shading plays a really important role in reducing heat gain in places with hot climates. With the increase in the use of glazed facades in our buildings, the lack of optimal shading can result in excessive heat gain inside the buildings. Key design strategies. 1. Outdoor shading devices help in allowing only the needed amount of natural light into spaces. Example, pergolas, louvres, screens, etc. 2. Planting trees as a natural buffer against the sunlight for shading and cooling inside the site. 7. Openings. The size, shape, location, and positioning of the openings can be curated to fit the needs of each particular space for the best climatic response. Key design strategies. 1. Place windows higher to act as ventilation points. 2. Place all the openings on external walls to allow cross-ventilation. 3. Prefer small openings to avoid heat stagnation inside the building. 4. Avoid west-faced glazing and provide south-faced glazing with horizontal louvres. 5. Addition of northern side openings for diffused daylight and less radiation. 6. Design the size of windows designed to fit the use, orientation and shading requirements. 7. Vertical operable louvre shutters over the openings for climate control throughout the day. 8. Walls. In hot climates, the primary issues we focus to avoid are excess humidity or heat gain that could affect the building either immediately or in the future. Key design strategies: 1. Use white or light color external wall finishes to reflect the heat and in turn absorb lesser heat. 2. Provide ventilated claddings behind the external surfaces of the wall driven by stack effect to remove moisture in humid conditions. 3. Use thermally insulated facades for air tightness and resistance against mold growth in the hot and humid climates. 4. Use walls as shading elements for exterior spaces based on the sun path. 5. Construct mud walls like rammed earth walls to reduce heat retention. 9. Roofs. Roofs are often where the most heat gain takes place as it is most exposed to the midday heat of the sun. Providing a roof that helps avoid excess heat penetration will be ideal. Key design strategies: 1. Lighter cool roofs help prevent excessive heat and sunlight from entering the building. 2. Ideal materials for roofing for warm climates are clay, terracotta, metal, slate, and so on. 3. Provide green roofs through rooftop gardening to help naturally cool the building and prevent heat gain. 10. Materials. The problems that directly affect indoor temperature and energy consumption can often be traced back to material usage. Key design strategies: 1. Utilize locally sourceable natural resources as building materials. 2. Choose materials with natural cooling properties. 3. Materials that are lighter in color and weight. 11. Landscaping and vegetation. We often talk about passive design at the building level. But at the site level, one of the only possible and powerful way to passively bettering the design is by landscaping it. Key design strategies: 1. Introduce indoor vegetation through vertical gardening and placing indoor plants near the direct sources of sunlight. 2. Grow gardens in open spaces to promote natural earth cooling at the site. Local trees and plants that grow in the locality will be a good way to protect the existing habitat and improve the site environment. 3. Rooftop gardening can increase the life expectancy of the roof by protecting it from harsh direct climate including rain and sunlight. It also acts as natural insulation against the heat and improves air quality. 12. Water as a cooling element. Water, with its natural cooling tendency, can create a huge difference in the cooling possibilities of a hot site. Key design strategies: 1. Evaporative cooling to lower indoor air temperature. Water is evaporated with the existing heat of air. When there is an increase in contact between water and air, there will be an increase in the rate of evaporation. 2. Pond, lake, fountain, waterfall or any other water feature inside the site can help with the natural cooling of the air inside the site. In summary, these passive design strategies can drastically improve energy efficiency and comfort in hot and humid climates. By harnessing the natural environment, we can create sustainable, high-performance buildings that benefit both the user and the planet. Thanks for watching, and don't forget to like, share, and subscribe for more insightful content.